jump right in here. Hopefully this part will be really easy. But there's some people that always hate factoring. Never seem to quite get it, so we'll see. Make a pause. That's the great thing about watching the video. You can pause where you need to and fast forward. Why don't you have a computer?
Why would I in the 21st century? How about because I live nowhere where you can use the internet?
You don't have a smartphone?
I have
Well, you can watch the videos on the smartphone. Do you get it on the internet on your phone? Well, on my big campus, I'm post.
I set my phone up in the very top right corner of my.
You could just drive down the road to where you get signal.
It's not worth it.
Anyway, I think you should.
Don't talk bad about my neighborhood ever again. Never point a foot.
I went and looked at a house in Cloverdale, and it was like in the middle. It was in the middle of nowhere, and I was like, "There's no way I could live here." Yeah. It was like we just kept driving, and then it was a gravel road, and I was like, "We don't even need to go into this house because I'm not living on a gravel road."
What are you trying to say?
I just don't want to live on a gravel road.
I live on a gravel road.
Wow. Thanks. So do
That's all I'm saying.
I.
I live in Waveland. It's not like I live in the big city, but I don't want to live in the middle of nowhere. My house is really good. You probably saw my house.
I doubt it.
There's only one gas station. I can see the gas station from my house. Shell.
Yeah. But you off.
Factoring. Remember, factoring is like undoing FOIL. So this is the F, the first. This is the O and the I, and this is the L. Oh, that L's right there. So it's really easy when it's just x squared, because the only thing that multiplies to give me x squared is x and x. And then factoring, it's all about asking yourself that question, knowing that you're looking for two numbers that multiply to give you the last number. So the only thing that can go in these other two spots has to multiply to give you 12. How do you know what to choose? You have to look at the middle number. So I always say start here and kind of work your way backwards. What multiplies to give me 12, that subtracts to give me negative 4. And John's exactly right. Negative 6 and positive 2. Negative 6 times positive 2 is negative 12. And you just got to check. Negative 6 plus 2 is negative 4. So I like factoring because it doesn't take a lot of time. It doesn't take a lot of paper. But you got to be able to ask yourself that question. And since this is an equation, we actually want to find the solution. So what's the next step that you do? Set them equal to 0. And ones like this, you probably don't even do all the work because you can just do it in your head. But really what you're doing is you're saying either x minus 6 equals 0 or x plus 2 equals 0. So you get x equals 6, x equals negative 2. That would be where that graph would cross the x-axis. Memories of this, right? It's really great if it's factorable. Do you want to do another one of those or you're good? Now my numbers are going to be off, but that's okay. This is now number 2. What about when there's a number in front of x squared? That's when factoring is a little bit more challenging.
If that number in front of it was like a perfect square, could you put that in the factor?
Say that again?
Like if it was not 9x squared, could you put like 3x on the bottom?
Maybe, if it worked out that way, but it could end up being 9x and 1x. Like it might not necessarily be 3x and 3x.
No, what if it was like 9x squared plus 2x plus 1? When you factor it out, instead of just putting x minus whatever, could you put 3x minus 1?
I don't think I understand.
Like, you put your two friends.
Right?
Yeah, and you just drawing x. If x squared by itself, but if it was like 9x, could you just put 3x plus 3x squared?
But it doesn't have to be 3x and 3x is what I'm saying. Like it could be, like if it was 9, it could be 3x and 3x that give me 9, but it doesn't have to necessarily be a perfect square. Like it could be 9x and 1x, because that also gives me 9. Like there's no guarantee that it's always going to be a perfect square. The only time you could do perfect squares is if it's like a difference of two squares, and this might be what you're thinking of. Like if it's 9x squared minus 4, this is what we call a difference of two squares. This is a perfect square, and this is a perfect square, and that's when you can factor that. If there's nothing in the middle, you could say 9x squared is 3x and 3x. 4 is a perfect square, 2 and 2. The only way you can get nothing in the middle is if you have the exact same thing in both parentheses, but one's a plus and one's a minus. That's great for factoring, but there's no guarantee that just because you see a 9x squared that it's always going to be a 3x and a 3x. Right. Sorry, it took me a minute to get that. Factor by grouping, this is what I feel like it works really well for people, that you just have to remember the steps. If there's a number in front, remember you multiply the first and the last number together. So I picked some little numbers here, but 3 times negative 1 is negative 3. And then you ask yourself that same question, but now you're looking at this number up here instead of the last number. You're saying, what multiplies to give me negative 3, subtracts to give me a positive 2 in the middle. 3x minus 1x, do you agree with that? So what multiplies to give me negative 3? 3 and negative 1. And how do I get a positive 2 in the middle? 3 minus 1 is positive 2. Factor by grouping. You take this middle number and you turn it into 2. You bring everything else down. And then what you have is a 4-term problem, which means you can group these together and you can group these together and you can factor it out. The nice thing is, on your homework tonight, you can choose whatever method you want. If you don't like factoring like this, you can complete the square, you can do the quadratic formula. You'll still get the same answer. But now I can look at this and I can say, what can I factor out of 3x squared plus 3x? A 3 and an x, right? And I'd be left with x plus 1. Remember, factor by grouping, you want the same thing in both parentheses. So Brindley said we could take the negative 1 out. And that's going to make that x plus 1. Then you pull out the part that's the same, so I can pull out the x plus 1 from both of them. And put together what's left, which is 3x minus 1. And now, just like before, definitely more work involved, but now you can set each one equal to 0, and you can get those two solutions, or those two groups. So you get x equals negative 1. And this one, you add the 1 over, divide by 3, x equals 1/3. And if I haven't stressed it enough already, fractions are much better than decimals. Don't write 0.3 if it's 1/3, right? That's really 0.3 repeating, so it's better just to leave it as a fraction. Vague memories of that? Again, the bad thing about factoring is sometimes you might start this, and there might not be numbers that multiply to give you this, that subtract to give you this, because sometimes it's not factorable if you have a square root answer or an imaginary answer. So that's where factoring kind of fails us sometimes. I think I'm going to skip the next one just because I feel like we kind of remember this one. Just give me a couple minutes to talk about the quadratic formula, do a couple examples, and then I'll let you start on your worksheet. The quadratic formula, I think I talked about this the other day in here, maybe it was 5th hour, but where the quadratic formula comes from is that if you complete the square for this, if you divide everything by a, subtract c over, take half of b and square it, you do all that, you take the square root of both sides, that's where you get the quadratic formula, which is this. And every single time, if you plug in what a, b, and c are and you simplify it, you can get those roots. So a lot of people like the quadratic formula because if you know the formula, you just have to plug stuff in. When we have a test in here, I will never give you this. Like, you need to know what the quadratic formula is. And it always equals x because those are giving you those x roots, right? Big mistakes I see with the quadratic formula is simplifying. We'll talk about that in a second. The other one is, for some reason, some people only put the square root over 2a. You have to remember that whole thing is over 2a. So make sure that you don't make that mistake. So let's just practice a couple of these, and this always works. Completing the square always works. So those are the ones that you can always go to. I think this is number 3 now, right? It's like a very long week this week. Back in Algebra 1, when I first teach the quadratic formula, I always say, like, write out what A, B, and C are, but I hope that you're able to do that now. Make sure you don't forget to take the signs. If it's a negative number, that has to come with it. Okay, do you need to make Justin move back to the back row?
No, I was talking.
I know. If you feel like you don't know the quadratic formula, my advice to you is write it on your paper as you do it, because by the end of your homework, I bet you'll be able to write it without having to look back every time. If you know it already, then obviously you don't need to do that, but make sure that you know that. We're definitely going to have our little, I call this chapter a big quiz, because it's definitely not going to be a 100-point test. But when we have our quiz next week, you do need to know this. So I'm just going to plug this in. I'll kind of talk through it if you want, and make sure we kind of agree. So it's negative b, so I'm going to take negative 9 plus or minus the square root of b squared. So that's 9 squared, I'm going to go ahead and say is 81, minus 4 times a times c, all over 2 times a. Make sure you're really careful when you're doing this under the radical. My advice is you can just type that straight in your calculator, so you don't have to make a negative mistake. Like, you can type in 81 minus 4 times 3 times negative 2, because the biggest mistake I see besides simplifying is people forget that that's a negative 4 and signs just get messed up. Got 105. Can you get 105 over there? You didn't get 105? I bet you subtracted. It's like, it should be negative 4 times 3 times negative 2 should be a positive number, right? So it should be, what's that, 24 plus 81? The other thing is simplifying. So the thing about, one reason I think I'm more of a completing the square fan sometimes is that when you complete the square, it's usually simplified for the most part for you already. You don't have giant numbers. For this one, you have to look at 105 and you have to think about if there's any perfect squares that you could pull out of that. It's an odd number, so right away a lot of things are out of the works, like we can't check 4 or 16 or any of that. So you want to kind of look at that, and I don't think, I might be wrong here, but I don't think there's any perfect squares that go into 105, but really big numbers, like sometimes it's even like over 1,000 in there. You got to go through and think about if you could pull out a perfect square, and then simplify from there. What about this? Can I cross out this 6 with this 9 and divide both of them by 3? No, you can't. No.
Same as yesterday, because there's nothing at the bottom.
Yes, yesterday we did this, and here's what I was saying about yesterday. If you want, you could break this up, and you could say negative 9 over 6 plus or minus the square root of 105 over 6. And this is why maybe I think it's a good idea to do this, because this you're allowed to do, and then you're right. Could you simplify 9 over 6? And you would get, what, negative 3 halves plus or minus the square root of 105 over 6. You're not allowed to just cancel this out, because there's nothing to cancel out here as well, right? It has to have the factor all the way through. Like, let's say there was a 3 in front of this 105. If there was a 3 in front of this 105, we could pull a 3 out, or we could cancel the 6 with both of them. But you can't just cancel this with this. Like, you're not allowed to do that, which is why I think maybe this isn't such a bad plan to do, because it doesn't make you just make up your own rules. Like, if you just break it up and simplify each fraction, you won't simplify more or simplify wrong. Well, no, you need to simplify 9/6. Like, this would really be your final answer. But you can leave it like this also, because there's nothing you can do here. Like, this is okay, or this is okay. And maybe as you work on your worksheet today, if you get one that needs simplified, maybe we can kind of talk about it. You're definitely going to have some with imaginary numbers, like with the one that we did on the board, 42 from your homework last night, but they won't all be imaginary. Do you want to do another one of these, or you feel good about this? It's not bad, right? Okay. I tried to leave enough room on here that you can do all the work on here, but if you need the back or you need another sheet of paper, just make sure you number it so I can read it. We will turn this in on Monday. Homework, we just turn in at the end of the chapter, but if I ever give you a worksheet, that will be due the next day, so make sure you keep that in mind. Also remember that I'm going to grade some of this, so I don't mind if you get stuck on something, if you ask someone something, but I definitely don't want to see people comparing papers, like let me check my paper with every answer on your paper. That's not okay by me. Also, if you turn in a paper and it's exactly the same as someone else's paper, like the same little mistakes, I'm going to be highly suspicious of that. So just remember, like, I want you doing your own work. Okay? You can do them any method that you want. Like, you're allowed to factor, complete, square. Oh, you mean like the one I